Right, guys. So these three APs, what are the next three numbers in them? Yes, 13, 15, 17. Three dots after these mean you can carry on. Yeah. And the second one, 15.5, 19, 22.5. Yeah. So here we are. What are we doing to this? Plus 2. This one. Plus 3.5. And down here the next three are 2.5. So that's sequences of numbers with a defined step every time. Exactly the same step. So, defining that more mathematically, when a sequence has a constant difference between successive terms, it's called an arithmetic progression. They often shorten that to AP. Examples of APs, well, you've already seen three, but the AP 1, 4, 7, 10, 13, where the common difference is 3, and then defined in the algebraic way, if it starts at A, and A is the first term, and D is the common difference, and the second term is A plus D, the third term is A plus 2D, the next term A plus 3D, and so on. Yeah, so that you're starting to get a way to find out what the nth term is from writing it in that way. Okay. Now, that brings us to a general expression for the nth term on there, play. General expression for the nth term of an arithmetic progression. If the first term of an AP is A and the common difference is D, then we can find the nth term from the formula nth term is equal to A plus brackets n minus 1 times D. Okay. Now in your bird book there's a derivation of that, not particularly difficult. If you're interested, you can find it in there. What I'm interested in is, can we use that to find the nth term of the particular progression? Yeah. So that's the first formula of the day. So for the AP 1, 4, 7, 10, 13 that we used as an example earlier, where the common difference D is 3 and the first term A is 1, the seventh term is given by 1 plus brackets 7 minus 1 times 3. That's equal to 19. If you add the expressions up to the seventh term, we've got 5 terms there, so the next term will be 16 and the seventh term 19. You're all okay with that? Yeah? So, that's the formula we're on at the moment. Let's have a look at some example problems. Determine the ninth and the 16th terms of the series 2, 7, 12, 17. So we've got 2, 7, 12, 17. So A is equal to 2. The common difference is equal to 5. Yeah. So for the problem, 2. What's the formula? The formula? Sorry? Yeah, that's the problem. What's the formula? A is 2. We're looking for the 9th term minus 1. We're going to multiply that by the common difference, D, which is 5. And you said it equals. So that's 8. 8 times 5 is 40. Which is what you said. I want to take you through the way I'm expecting you get a problem like that in your assignment. I want you to lay it out, not just write the answer out, not just write that bit. You need the formula, numbers in, answer, and any rearrangement in between. Okay? So B, 13th term. You've already given me the formula, so it is 2 plus 13th term minus 1 times the common difference, 5. And it equals 62. Yeah? 16th term, is it? Oh, I beg your pardon. 16th term. So that is 16. So that's 15 times 5 is 75. 77. All right. 77. So finding the value of the nth term, not particularly difficult. You can just use the formula and put the numbers in, and away you go. Okay? Everybody happy with that? Okay. Next problem. The 6th term of an AP is 17. And the nth term of the 13th term is 38. Determine the 19th term. How are we going to tackle that problem? Well, we know nth term is equal to I n minus 1 times D. Yeah. Which things do we know there? We know that sixth term is 17. Yeah. So let's write 6th term here. For the 6th term, 17 is equal to, what's A? So all we can do is say it's equal to A. N in this case, 6 minus 1, and what's D? Yeah. And 13th term, we know that 38, the value of the term, is I 13 minus 1. That's A plus, isn't it? Sorry. That's neat, isn't it? All right, we can resolve this bracketed term, so we can say us an a plus 5d, so 17 is a plus 5d, and this one is a plus 12d. How do we solve that problem? So what we've got two equations. Equation 1 is 17 is equal to a plus 5d. And we've got equation 2 where 38 is equal to a plus 12d. What's the term for two equations like that? Simultaneous equations. A and D, remember A is the first term, so it has to be A is the same in both equations. Yeah. D is the fixed jump in the progression, so that's fixed for both. So what do you know about solving simultaneous equations? How can we solve that? Yeah? Give me in our method. Anyone? We need a way to get rid of one of these two unknowns. So we've only got one unknown. What can I do? Subtract equation 1 from equation 2. And I've chosen 1 from 2 because I don't then end up with any negative terms, because 17 is smaller than 38 and 5d is less than 12d. So what I'm doing is I'm going to take that equation there and I'm going to subtract it from equation 2. So if I draw a line under there, and I'm going to do a subtract. 38 minus 17 is 21. Yeah. A minus A is A, take away A. 1 apple, take away an apple. What have I got left? 0. 12d minus 5d. Yeah. So I've got now 21 is equal to 7d. I've only got one variable. Yeah. So I can go, therefore, d is equal to 21 over 7 equals 3. Yeah, so I've found d. Now what can I do? Yeah, I can put d equals 3 into either of those two original equations, yeah? Let's choose equation 1. So we've got 17 is equal to a plus 5 times 3. Yeah. Equals a plus 15. Therefore, a equals 2. Yep. So now we've extracted the values of a and d. we can solve the original problem, which was to find the 19th term. Therefore, 19th term is a plus n minus 1 times 3. A we found to be 2. N is the 19th term we're looking for. Multiply that by 3. Yeah. So that's 18. 3 18s are, darts players should know, 54. Am I right? So that's 56. Okay. So just to summon that up, go back again. This is where we've not got, we don't know the first term, we don't know the common difference, but we do know the value of 2 of the terms in the series. So we can form 2 simultaneous equations from that information and solve them to find the value of A and D, and then we can use the value of A and D to find a particular term. All right? Determine the number of the term whose value is 22. In series 2.5, 4, 5.5, 7. So what do we know from that question? We know that I is equal to and D is equal to I'll give in this case. Right? So we want to know the term where nth term is A plus n minus 1 times D. What are we looking to find here? N. We're looking to find n. Yeah. So we've got, how do we rearrange that formula? To find n. Where do we start? If we divide both sides by D, this is what we have to do. And effectively, what you have to do is that. So they cancel there, but you're left with A divided by D. Has that helped? We need to take away A first. Remember what we said with this rearranging formula? You're almost doing bid mass in reverse. You have to do plus and minus first, and things inside brackets come later, last. Yeah, and multiplication after. So the first thing we do is subtract A. So the nth term, I'll use that, minus A is equal to n minus 1 times d. That's after subtracting a. Next. Divide by d. Let's put subtract a in there. So if we divide by d, now the brackets are gone now. Next, considering we're trying to find n, yeah, add 1. So we get n is equal to nth term minus a over d plus 1. It's the value of the nth term, remember? So that in this question is 22, isn't it? Yeah, value of nth term. (22) minus a, what was a? D. Plus 1. What that come out to, you put it in your calculator. The 14th term has the value 22. Okay? Right, on somewhere close to the last page of your handouts, I reckon. Questions, and you'll notice there's some gaps because I took questions out from the book. 1, 2, 3, and 5, and have a go at. Right, about 20 minutes. Necessarily get them all done.